Hey guys, welcome. Waiting for you guys to come hop on in so we can get started today. I hope everyone's surviving the rain. It's drizzling here in Jacksonville. It's good to see you guys. Make this a little bit better. Glad to see you guys are around, not looking good. Virtually, it sounds good. Great. Good to see all you guys in here, saying hi, saying hello. We'll give a few more people because I feel like if I give any announcements, people are going to ask about them in just a minute. So, Sergey asks, when is our next knowledge check? Next week, it should be soon. So the knowledge checks, you should have one basically in the middle of the exam and then right before the exam. So I think it will happen this week. I'm not actually sure. I can double check. There is a way, and they are shown in Alex. So you should see that here pretty soon. Is the problem solving worksheet on Canvas? Let me see if I can pull that up and y'all can watch me type on my computer. Because apparently it's not. That'll be annoying. Sorry. I thought I preloaded it last week. Whoops, hold on. Let me upload that for you very quickly. I mean, you can watch me upload it longly, but I will do this as fast as possible. It is now on Canvas, not that you can see it. So, Dammy and Marlo, you were both correct. Somehow I thought that I'd uploaded it, and I didn't. So, if that happens in the future, which hopefully it doesn't, hopefully I get my life together, just send me an email. I am happy to upload it. I would like to apologize for not having it, which means that we will work. I will try to give a chance for you to solve the problems in the thing. So, does anyone, let me see, are there any other questions? Does anyone have any other questions before we get started talking about using balanced equations and limiting reactants today? Well, I have some information. Number one, next week, we will be here on Monday because next Wednesday is our exam. So next Monday, I will run an exam review session. It'll be just like today's session. I will, in fact, actually put the worksheet up. Sorry. And then we'll work those problems. If you have other topics that you want to ask questions about, feel free to come. It will be at 4:30. It'll be at 4:30. It'll be just like class from 4:30 to 5:45. You can come at 4:30. You can leave. You could watch it later. If you have to work, it's not a problem. Next Wednesday is our exam. Yes, next Monday is a YouTube Live. Unlike last week where it was in my office hours. This is just a YouTube Live review session for the exams. And then it will be, that does mean that I will be here and not in my office hours. So Jenna asks, do you know when the quiz grades will be up? My goal is to have them up Friday. I'm working very hard to get them up earlier. They will get up no later than Monday. That way you guys can learn from them. But my hope is to get them out by Friday so that you guys can see that information. The mini exam is roughly 25% of an exam. So it's 25% points, a little bit longer than you'll get on the exam per point. So the exams are 200 points. It'll be the same format. Some of them you'll have to show work. Some of them you don't. For naming, you don't have to show your work. You kind of either got it right or you got it wrong. For anything with math, or drawing, you'll have to do that. Well, I've already spent several hours grading, so I'm going to finish grading this. But, you know. Oh, no, it's coming along. As soon as they're done, I will release them. So on Friday, the announcement will be a regular announcement. All of the exam information will come out in a separate announcement so that it's not like too much stuff all in one. It will say like exam 1 information. If you did the practice upload, there will be a similar practice something to make sure that your lockdown browser is set up. It will also be worth 5 bonus points. It will be in the announcement. Probably not the Friday one, probably one a little bit later. Please make sure you do that. It's worth bonus points. Everybody likes a bonus point. And it will make sure that next Wednesday, your computer doesn't have a meltdown. If you have issues, contact me or the IT help desk. Any other questions before we talk about question number 1? I said it will be more than 20. My guess is between 20 and 30 of similar complexity, similar readings. Make sure you read the entire question. Sometimes it'll ask you to do more than one thing, one on Canvas, one on paper. Other information, if you guys could number your problems on your work, that'd be awesome. So my guess is it would be less than 30 questions, but I don't make any promises. So other questions. Otherwise, we can do some limiting reactants. Yes, the exam, you will have 75 minutes. So it will take the same period of time that we usually are here instead. So the exam is 75 minutes, 200 points. The questions, so Sky asks, are the questions in order for the amount of points, lowest to biggest, or just random? The order of points is kind of random. I am working to find a way to include that information up in the top graphic, like what the point values are for each problem. And so hopefully that will be informative. I'll try to give you an info about what that looks like. Gabe, it won't be that bad. It's only 75 minutes, and then it'll be done. Christopher, you're fun. I followed along. It's because Canvas calls them all quizzes. The mini exams are 22 minutes. Your exam will be 75. And I'm always happy to answer your questions. Anything else, go ahead and drop it in the chat. I'm going to throw up question number 1. So Ashana says, it shows you the point values, but I think people are asking if you could try to figure that out without having to click on each one. In my ideal world, in that graphic up on the top right, where it says how many questions, it would also have like a parentheses that's like 5 points, 6 points. Or where like number 2 is the periodic table, it would say periodic table, not just like blank. So that information, I'm going to try to put it up in the top. So, no, the mini exam time is, the idea with the mini exam is it's a quarter of the exam. So it's roughly a quarter of the time and a quarter of the points. There will be some helpful tips and tricks in the Friday announcement on how to better manage your time and how to, if you struggle to finish the mini exam, how to ensure that you do a little bit better on the regular exam. These are all great questions. I'm always happy to answer them, but let's look at this. So, Ammonium phosphate, NH4,3PO4, is an important ingredient in many fertilizers. It can be made by reacting phosphoric acid with ammonia. What mass of ammonium phosphate is produced by the reaction of 15.392 grams of phosphoric acid? And in this case, I've given you a balanced equation. In the exam, sometimes I will say, using the, in all caps, unbalanced equation. Make sure that you're on the lookout for that so that if there's an equation that needs to be balanced, you obviously balance it. So we have a balanced equation, and so the first thing we want to do is to calculate our molar masses. So we're going to have to do that often. Once we do that, we can convert the grams of phosphoric acid to grams of ammonium nitrate. So ammonia, NH3, has a molar mass of 17.04 grams. H3PO4 has a molar mass of 98.00 grams. And NH4,3PO4 has a molar mass of 149.12 grams. So don't forget, the molar mass can be calculated in this case. You can then just sum up each of the elements in there. So in order to calculate this, we're going to take our 15.392 grams of H3PO4. Then we're going to convert from grams to moles. So we're going to do that by dividing by 98.00 grams of H3PO4. Oh, I'm going to run out of space. Hold on. We'll make it work. And 1 mole of H3PO4. So, in order to convert grams of reactant to grams of product, we need to do basically 3 steps. Step 1, convert to moles. Step 2 is going to be convert moles to moles. So in here, we're going to use our balanced chemical equation. So in our balanced chemical equation, there are 3 moles of N2 for every 2 moles of NaN3. Oh my gosh. Hold up. Don't write that down. I was working number 2. In 1 mole of H3PO4, there's 1 mole of ammonium phosphate. There we go. So the last step is going to be convert from moles to grams. And so in this case, there's going to be 1 mole of NH4,3PO4. And based on our calculations, there are 149.12 grams of ammonium phosphate. When you plug this into your calculator, let's write up here. Your answer is going to be 23.421 grams of ammonium phosphate. I know it's a little, oh wow, can't see anything. Better. No, that's a 4 on ammonium. So Amanda asked about a different periodic table. You've been provided several in the Canvas site. My recommendation is to print off the one that looks like this, where it does have the names. You can use any periodic table you like, but the one I provide will not have the element names on it. So, what questions do we have about this calculation? How do we feel, and how do we feel about this type? Does this feel easy? Does it feel hard? Does it feel like we just like way leveled up what we've been talking about? So Christopher asked, could you do produce/consumed? Christopher, I'm not entirely certain, and I'm not sure how for you to answer that question in the chat box. But I'll be honest, I don't quite understand which produce/consumed question you're asking. If you want to send me an email about what you're talking about, I'm happy to look at it. I like that it's making sense. Ooh, Jack Daniels said it looks hard. So Dammy asks, how do we know when it's 1 or 2 moles? So these values right here came from the balanced chemical equation. And so our balanced chemical equation is here, where we have 3 moles of ammonia plus 1 mole of phosphoric acid gives us 1 mole of the ammonium phosphate. So in this case, we can then use that information. Yeah, Dean, I'm happy to go over it again. Christopher, I'm going to need like way more details than what you wrote in the chat box. So send me an email with, if you could write out what you're doing, then we can look at that. Because I think your method might work, but it may only work when you have a 1-to-1 reaction. I'm not sure. Oh, I see your point, Amanda. It is unlikely that I will give you the element symbol names all of the time. You are expected to know most of those elements, or at least be familiar with them. When I pick something quite odd, I will pick that. I didn't feel like any of the ones on the mini exam were that outrageous, but I will take that into consideration when I write the exam. Thanks for the feedback. So Dean asked for me to look over this again, or to walk back through it. So when we look at this information, in order to convert grams of product or reactant to grams of something else, the first step is to convert grams to moles. Now, I've done it all as a single step. I like big, long things in this case. So from here to here, we divided by the molar mass. Then we used our balanced chemical equation. And I know the optics are a little bad because the computer's like not straight on. Sorry. I'll fix that for the next problem. So then we'll have 1 mole of ammonium phosphate divided by 1 mole of phosphoric acid. This 1-to-1 value came directly out of the periodic table. From here, we're going to convert using the molecular weight back from moles to grams. Now, I write down a lot of steps. One, that's kind of my gig. I'm the professor. But the other thing is it helps me know that I'm crossing out the right units. What am I saying? Let me get a red pen. So if you were to think about this like a dimensional analysis problem, meaning if you wanted to convert inches to feet or something else, grams of phosphoric acid cancels out here. And now our units are moles of phosphoric acid. We're going to cancel that unit here. So what you want is to make sure that your units cancel as you go down the line to end up with this. And so, Dean, I think that's Dean, do you have other questions? How did this explanation assist? What are your thoughts when we look at it this way? Quilt. All right, I'm going to move us back here. The SI leader is here. If you have questions for her, you can drop them in the chat. She will respond to you. I highly recommend going. She and I work together a lot to try to make sure that we are doing the absolute best for you guys during this remote period of time. So, she's my favorite. So, our next question, glad it's good, Dean, is this question here. So, I'm going to give you a chance to read it when it's not on the board while I erase. If you have pulled up the PDF, you're going to notice that there's a typo. I had a mental moment, and the equation in the PDF is incorrect. It has the wrong balanced equation. So if you do it that way, I'll give you what the answer is. If you notice that in the last 10 seconds, that we can update that as well. So our second question, sorry. Question number 2, airbags in cars are filled through the decomposition of sodium azide using the following balanced equation. Over here. How many grams of sodium azide are required to form 13.56 grams of nitrogen gas? Now, the balanced chemical equation is that 2 moles of sodium azide produce 2 moles of sodium and 3 moles of nitrogen gas. So, in this case, we're going to set it up the exact same as we did in the exact same way that we did the previous time. Hey, Matt, I'm going to need some more information about if you're asking about this equation here being unbalanced, or if you're looking at the PDF. In the PDF, it is unbalanced, or balanced wrong is probably the best way to put it. It is very awry. But in this case, this is the correct balanced equation. So we're going to set it up. There are 3 steps. Convert to moles, moles to moles, moles to gram. And we've looked at all of these steps multiple times in order to get us here. So in this case, we're going to take what we know, our 13.56 grams of nitrogen gas. And we want to convert that into 1 mole of nitrogen gas. And so 1 mole of gas is 28.02 grams of N2. This value came directly from the periodic table. There's been a couple of questions. People are using, I don't want to say different periodic tables, but different periodic tables have different number of digits after the decimal point. I will always round to 2. So in all of these, I rounded to 2 using the traditional rounding rules, 5 and up, round up, 4 and down, round down. And so that's where this number came from. You could also use the much longer number. Sometimes you will get slightly different calculations, but this is a place where if your work is complete, I can follow that work and give you guys more feedback in that case. So Once we have this, we're going to use our balanced chemical equation, the stoichiometric coefficient, you know, the big numbers at the top and the front of any of these values. So there are 3 moles of N2 for every 2 moles of sodium azide. So from here, we want to convert, our last step is to convert moles of sodium azide into grams. So in 1 mole of sodium azide, that weighs 65.02 grams of NaN3. From here, we can plug this into our calculator, and our value is 20.98 grams of NaN3. We want to double check our sig figs. In the problem, we started with 13.56, which has 4 sig figs. So now we have 4 sig figs in the answer. Jack, you are exactly right. This is quite similar to the first question. Unlike other weeks where it feels like we're kind of like hopping from topic to topic, several of these questions are the same general genre. So I think we have one more like this. Yes, we have one more exactly like this, so number 3. Then we'll do some percent yields, then some limiting reactants, and the like. So what questions do we have about this calculation? Let me get out of the way so you can see it. If you have none and you thought it was easy, you can go ahead and write that in the chat. Nice. I love it when you guys say it's easy. Makes me happy. Oops. I will leave that. Oh, man. Leave it up here for you guys to just like read, kind of think about how you would set it up while I erase the board. Nice. I like it when you guys are like, we're all on board. Okay. So our next question is about the decomposition of potassium carbonate, potassium chlorate, and it can produce small amounts of oxygen gas. How many grams of O2 can be prepared from 4.50 grams of KClO3 using this balanced chemical equation? Again, I will tell you if it's not balanced. This equation doesn't say that it's balanced or unbalanced, but I will always, if I'm asking you to balance it, it'll say balance this equation. So in this case, we're going to do almost the same thing. We're going to take our 4.50 grams of KClO3, multiply or divide by the molar mass of 122.55 grams in 1 mole of KClO3. Using our balanced equation, we know that there's 2 moles of KClO3 for every 3 moles of O2. Every 1 mole of oxygen gas weighs 32.00 grams of O2. So this is very similar to what we've done the last 2 questions, just a different thing. So what we've learned is that we could convert from any product or reactant to anything else using this method right here. So in this case, when you plug it in, you get 1.76 grams of oxygen. So what questions do we have? Do you have any questions? I'm sure you have questions. Oh, I got a thumbs up. I feel like that means y'all liked it. So if you thought this was equally easy, you can write that in the chat. If you have a question, you can drop that in the chat. If you just thought that was super easy, you can let me know. And we will move on to number 4. Hope that's great to hear. They say, these I can actually follow my steps. I like it. I think some of the early part of chapter 3 is very disjointed. The end of chapter 3 kind of pulls it all together. Yes, these are going to behave somewhat similar to a conversion calculation. Nice, nice. So I'm going to let you guys read this while I erase the board. So imagine you are working on ways to improve the process by which iron ore, Fe2O3, is converted to iron, using this balanced equation, which I'm not going to read. If you start with 150 grams of Fe2O3, what is your theoretical yield? If you isolate 87.9 grams of iron, what is your percent yield? But Gabe has asked us to wait. Oh, I got you. Always happy to, I mean, we can't go back because I don't know how to like rewind in real time, but I got you, Sterling's got you. We're here for you. So, that'll make me happy. Back to our problem here. So now instead we've asked for our theoretical yield. It doesn't tell you what your theoretical yield is up. It will on the exam. This question needs to be updated. So in this case, we're going to look at iron. So we are trying to improve iron. So we could have also, I can rewind myself. I'm going to have to look into that. Because it asks for iron here, we can do that. So we are going to go ahead and calculate using 150 grams of iron ore. How much iron do we get? We're going to take our 150.0 grams of Fe2O3. The molecular weight of that is 159.7 grams of Fe2O3 and 1 mole of Fe2O3 using our stoichiometric coefficients. And 1 mole of Fe2O3, there's 2 moles of Fe. And 1 mole of iron, it has 55.85 grams of Fe. Similar type of equation. In this case, just like before, except now it asks for the theoretical yield. Amanda just commented, would it tell you what it is on an exam? Yes. It's just an I just forgot to add what it was. Ordinarily it would. If it didn't, I would accept both, as long as you gave me the yield of a product. So from here, you can plug this into your calculator, and you should get 104.9 grams of Fe. So we have the right number of sig figs, which is still 4. So this would be part, we'll call it A. Part B asks about percent yield. So if you only isolated 87.9 grams of iron, what is your percent yield? So in this case, we're going to take what you isolated, 87.9 grams, divided by 104.9 grams, times 100, and that gives you 83.8% yield. So what questions do we have about percent yield? Percent yield is relatively easy, or straightforward is probably the best thing. What you got divided by what you should have gotten. So the theoretical yield is how much you expect to get. And in this case, if we only are provided one of the reactants, you assume that the other is in excess. So this would be a non-limiting reactant type of question. So what other questions do you have? After this, we're going to take a slight shift, maybe slight, maybe big, into limiting reactants. So we're going to take a step. The next question is quite busy. We have a lot of steps, but we're going to get through all of it. If you've got any questions, drop them in the chat. Otherwise, we'll move on. Nice, nice. Ooh, we got some good questions. So if it is percent yield, you do multiply by 100. The number that comes in the problem is usually the actual. Yes, if it says you got this much, that is the actual. And I will let you guys read. I'm going to erase the board. Okay. The actual yield. Yes, the actual yield has to be provided, usually in the question. Or if you were in lab, it is how much you got at the end of the sample. So the actual has to be provided. So number 5, it says, if 15.289 grams of aluminum hydroxide reacts with 17.239 grams of sulfuric acid to create aqueous aluminum sulfate in liquid water, how many grams of aluminum sulfate would be created in this reaction? Question 1. How many grams of the excess reagent remain? Question 2. If they only collected 12.403 grams, what is the percent yield? And the 12.403 grams relates to the aluminum sulfate. In this case, this problem is quite similar to something I would ask on an exam. A couple of things here. This problem would be worth at least 20 points, probably closer to 30. It's a lot of work. It's going to be delineated. It's going to ask you to do a bunch of different things. Make sure that you do all the things that I want. This type of question also comes from Alex, or similar to Alex. So I'm going to try to give you and highlight the moments where Alex may or may not make you crazy over the next couple of days. So in this equation, the very first thing we need to do is write a balanced equation. Well, I guess we could also, I'm going to give you guys a choice today. I'm more than happy to give you guys 10 minutes to work on 5, and I'll put number 6 up since I didn't post the worksheet early. Do you guys want to try them on your own, or would you just like me to go ahead and work them? I'm going to give you guys about 45 seconds, maybe a minute in the chat. While we try to figure that out, if you guys want me to work it, say work it. I don't. Hey, Allie. You guys can go ahead and drop it in the chat if you guys want to do, if you guys want to try this problem by yourself. If you don't, I'll go ahead and work it. But either way, I'm going to write the balanced equation on the board. Ooh, Sarah votes for just work them. I like that. So, I will start here. We got 2 votes for work it, so we'll go ahead and do that. Ooh, 3. So the very first thing we're going to do is write a balanced equation of 2 aluminum hydroxides. Well, y'all just make my little heart happy most of the time. Pretty much all the time. I will work both of them. We'll work them all together. Thank you for your input. Okay. So, this problem has a lot of steps. So, operation number 1, I'll try to write steps over here. 1, balance equation. So now we have a balanced chemical equation. You can expect to be asked to be provided a word equation and then pull that together. So now it asks, now we need to identify the limiting reactant. If you've watched my YouTube videos, not this one, but the other ones, you'll notice that I do limiting reactants a little bit differently. It's, oh, that, no one can read that. It's liquid, which I don't think that helped at all. So, in this case, we want to identify the limiting reactant. We're going to do it just a little bit different than perhaps if you watch different videos or than you did in high school. You can do it both of these ways. The excess reagent question is hard to do in the way that you may have done it before. So, in this case, my preferred preference is to identify the limiting reactant by calculating reactant to reactant. So the first thing I'm going to do is take my 15.298 grams of aluminum hydroxide, which is 78.01 grams in 1 mole of aluminum hydroxide. Based on the stoichiometric coefficient, there's 2 moles of aluminum hydroxide for every 3 moles of sulfuric acid. For every 1 mole of sulfuric acid, it weighs 98.09 grams. So that means you have to have 28.85 grams of sulfuric acid. So, what I have calculated is how much we have 5.298 grams of, or 15 grams of aluminum hydroxide. You have to have 28 grams of sulfuric acid to use that. Sorry about that. It is 2 point, as Dammy said, I had the wrong number way over there, and so I fixed it over here. So, but we only have 17 grams of sulfuric acid. This tells us that the sulfuric acid is our limiting reactant. So, HLR equals H2SO4. So Hope asks, why did I pick that one first? Because it was the first one in the problem. You could have also started with the 17.293 grams of this is still wrong. Hold on. So, Sterling, I think I had a moment. I don't know where the 0.293 came from. The 15.289 came out of the problem. Now we're all on the same page. I'm watching the chat. You guys are all coming along. So, the limiting reactant is the reagent that gets used up the first. Now, this information may help some of us identify which one is the limiting reactant. But maybe you're still like, I don't understand. That's okay. A limiting reactant is if you're making a sandwich and you have cheese and bread and you run out of cheese, that's your limiting reactant. It determines how much product you could make. So we have a limiting reactant and a excess reagent. Excess is how much is left over. So now I'm going to take my 17.293 H2SO4, and it has 98.09 grams in 1 mole of H2SO4. There are 3 moles of H2SO4 for every 2 moles of aluminum hydroxide, and every 1 mole of aluminum hydroxide, there are 78.01 grams. When we plug this into our calculator, it says that we are required to have 9.1686 grams of aluminum hydroxide. Okay. So in this case, this calculation is maybe different because a lot of times students want to do the convert both of these to product, and the one that makes the least product is the one that's limiting reactant. That is true. That will identify the limiting reactant. It doesn't help you answer how much excess is left. And Alex will ask you that 100 times. I will also ask you that on the exam. So we know that this is the limiting reactant. So if it were to ask you how much is left of H2SO4 and aluminum hydroxide. This is slightly deviating from the question up here, but not a lot. So the aluminum hydroxide, we started with 15.289. Minus 9.1686 grams. And I didn't finish that calculation on my paper. So we get 6.120 grams of aluminum hydroxide. This is the excess. So the excess is how much is left over. Let me move out of the way so you guys can see. But Alex will ask you how much is left of each one. So how much sulfuric acid is left can be quite perplexing. So the reason the H2SO4 amount is more difficult is because we, for some reason, feel like 0 is the wrong answer. In this case, 0 grams of sulfuric acid is left because this is all used, where this has leftovers. So this tells us how much is left over of both of these. We are, I promise, going to get to the part of the question about how many grams are you going to make. But unfortunately, I'm going to have to I'm going to try not to make y'all dizzy. Okay. Whoa. So now in this board space, we will move it back to where you can see the rest. Now let's talk about the rest of that equation that asked how much aluminum sulfate. So I'm going to have to write a little bit smaller because I've kind of used all my board space, but that's not bad. So in this case, the question is, this is just back to the same type of calculation we did at the beginning of class today, where we take a reactant and convert it to product. So we're going to take our 17.293 grams of sulfuric acid, divide by the molar mass of 98.09 grams and 1 mole of H2SO4. Then we're going to convert to moles, there is 3 moles of H2SO4 for every 1 mole of aluminum sulfate. And the molecular weight of aluminum sulfate, or the molar mass in 1 mole, is 342.17 grams. So we get 20.107 grams of the aluminum sulfate. Zach, that is 100% correct. So now we've been able to do just this standard calculation. I'm sorry for the poor board work. I just ran out of space. And I want to be able to move the computer back and show the other part again. So this would be the answer to part 3. The last part is the percent yield, which we will try to do at the bottom over here. So we only collected 12.403 divided by 20.107 multiplied by 100, and that gives us 61.685%. I hope we have enough cord. I know all you can see is my face, and that's not really what I was going for. But good enough. So as we look at this information, what questions do we have about limiting reactants? We have some great questions already. Why did we use the 17.293? This is our limiting reactant, and so it will control how much product is made. So because there is none of this left, we know that all of the sulfuric acid is going to be converted into the aluminum sulfate. There is leftover aluminum hydroxide, so we can't use that value. Sarah asks, what is the 20.107 the answer for? Good question. The 20.107 grams is how much of the product would be made. So that would be how many grams, I guess the first question it asked. In the problem, it's the first question. If we put grams in our final units for the answer and not type the element, we'll take off points on the quiz. So Hope asks, if you put grams for the final units in our answer and don't type the element, will it take off points? I don't. Alex has its own picky things. I would prefer that you add units so that I can tell what you're getting to. But in that case, likely you in the Canvas quiz, it is less important that you have the G in there. Yes, Jenna, you can send me number 6, and I am more than happy to look at it. Other questions, although I don't know how I can, let me try to get out of the way. What other questions do we have? If you have none, you can write none in the box. If you are so I have no idea what's happening, you can just draw a smiley face in the box. Amanda asks, where did the 12.403 come from? In the last part of the problem, roughly about right here, it asks if you only collected 12.403 grams, what is the percent yield? So we use the 17 value here because that is the limiting reactant. So the limiting reactant tells us how much product we're going to create. All right, I'm getting some smiley faces. We're going to talk a little bit more here in just a second about limiting reactants. So in this case, this value is because it's the limiting reactant. So before we talk more about the question, let's talk about what a limiting reactant is. If you have 10 slices of bread and 6 slices of white cheese, any cheese, just sliced cheese, and we're going to make grilled cheese sandwiches. 2 breads plus 1 slice of cheese, so you have 10 bread and 6 cheese. What you're likely picturing in your head is that you could make 5 sandwiches. How did I get that? We're just going to have to do it without board work. So a grilled cheese sandwich takes 2 pieces of bread and 1 slice of cheese to make this sandwich. The limiting reactant is what's going to go away first. If you make all the sandwiches, you will use up all 10 slices of bread. And there will be 1 excess slice of cheese left. So if you wanted to calculate how many slices or how many sandwiches you were going to make, you're going to use the limiting reactant. Because if you had used the cheese and there were 6 slices of cheese, that will make 6 sandwiches. But you're going to run out of bread before you make all the sandwiches. So the limiting reactant is the thing that runs out first. And so with the limiting reactant, we can't determine how much product there will be from the other. If the excess reagent is used to determine the product, you will in fact tell me you're collecting too much product. But the limiting reactant in this case, sulfuric acid, is what we want to use to determine how much product we made. The product we made is in this kind of convoluted, where we took our limiting reactant of sulfuric acid, converted into aluminum sulfate, grams of aluminum sulfate. So if you had run that calculation with the amount of aluminum hydroxide, you would get way more than 20 grams. So you would be telling me you're making more than you have supplies for. So when we think about a limiting reactant, it's just about which one gets consumed first. I'm going to talk about other limiting reactants to kind of help you guys think about it. If you, in the in-person class days, if you went to a party or a gathering or a friend's house and they had different candy or cookies or anything else, we all know that the best stuff gets eaten first. If you were trying to make some sort of a graph, the stuff that gets consumed first is the limiting reactant. So, probably a better example, because that one was really bad, is Thanksgiving leftovers. It was a few months ago. You've probably gotten rid of the turkey vibes from your brain. But in my family, green bean casserole is really the biggest. That runs out first. But then there's always like cranberry dressing. No one really eats it. So we have a lot more of it. We have all this excess stuff. So the limiting reactant is the thing that gets consumed faster than others. So in general, What questions or thoughts do we have about limiting reactants? How do they work? What do they do? If you feel like you are better processing limiting reactants, feel free to write that in the chat. If I saw some smiley faces, we're trying to kind of pull it all together. So for those of you who were kind of like, I think I just got off on the wrong bus or the wrong stop, how do you feel now? Are your smiley faces, you still have a smiley face? Are you still confused? Are you more confused, less confused? What thoughts do you have? If you fully understand this, you can go ahead and write like, got it in the chat. If you want to talk about it some more, I can. What thoughts do we have? Nice, Zach. It looks like a little bit more of you are kind of trying to say like, okay, I got it. So Mary asks, how can you get more problems? So there are a couple of different examples. There are a couple of places you can get example problems. On my YouTube channel, in the chapter videos, there's more examples at the bottom. You can do those. I also suggest problems out of the back of the book. And there is a way that you can make Alex redo it. There's also the chapter worksheets that I've created. So you can use all of those to try to get more problems to work. So it looks like most of you guys are doing pretty good. So our last, I'm gonna let you guys read that while I erase all this, and then we'll work that one. And as always, I will stay here and work this last example. If you've got to go, it will be on the channel in this case. So Amanda asked, well, we need to know the states for the equations for these problems. So if the states are provided, you will need to write that down. If it doesn't, no. Will a chemical equation be provided and you balance it? So Amanda asks, will I give you a balanced equation? I will either say, using the following balanced equation, or using the unbalanced equation. Or it will ask you to come up with the equation. I haven't written the exam, but I don't typically ask all three of those type of things in the same equation or in the same question, because that's a lot of information. So if I'm asking you about balancing an equation, it will say, balance the following equation. My hope is that you'll be able to know what I'm asking you for in the equations or in the questions. So if I give you the states, you have to have the states. If I don't give you the states, You don't need to come up with those. Does that help your question, Amanda? I'm glad you guys are enjoying it today. So in our last question today, gaseous methane, CH4, reacts with gaseous oxygen to produce gaseous carbon dioxide and gaseous water. What is the theoretical yield of carbon dioxide formed from the action of 4.65 grams of methane and 34.0 grams of oxygen gas? So this is quite similar to the last. We're going to start by writing a balanced chemical equation. We're going to have CH4 gas plus O2 gas goes to CO2 gas plus 2H2O gas. So now we have a balanced chemical equation. We have that. It's always step one. If you don't have one, you need one. If you got one, use it. So now we have a balanced chemical equation. But it asks us, what is the theoretical yield of carbon dioxide if we have 4.65 grams of methane and 34 grams of oxygen? I'm going to pick either one of the reactants to figure out the limiting reactant. Now, in this case, you could just convert both reactants to products, and it will give you the theoretical yield. I am going to do it a different way. So we're going to take our 4.65 grams of methane, and there are 16.05 grams in 1 mole of CH4. There's 1 mole of CH4 for every 2 moles of O2, and 1 mole of O2, there are 32.00 grams, which gives us 18.5 grams of oxygen. This tells us that in order to use all 4.5 grams of carbon dioxide, we need 18.5 grams of oxygen. These 18.5 grams of oxygen is less than the 34 grams of oxygen that you had started with. Therefore, this is a limiting reactant. So from here, we can use this value, 4.65, to convert to carbon dioxide. And there's 16.05 grams in 1 mole of CH4, 1 mole of CH4 into 1 mole of CO2. 1 mole of CO2 is 44.01 gram of CO2. Therefore, there are 12.751 grams, and that gives you 12.8 grams of CO2 with sig figs. So what question, there we go. What questions do we have about this example? This is a little bit, it is way more straightforward than the one we did before. It's a little bit less work. It's just asking one question. How much carbon dioxide do you get with this starting material? If you got no questions, if you thought that was easy, you could drop that in the chat. If you have a question, let me know. What do you guys think? Oh, right. I'm standing in the way. My bad. Nice, Ashana. Good. I'm glad you guys are doing good. Good. What other questions? So Matt, I just picked either reagent to start with. It's not always going to be the smaller value. In this case, I just picked one. You could have started with the oxygen, and that would have also identified the limiting reactant if you had desired. Miri asks, which one of these would I likely ask on the exam? Both. But I like the previous question, number 5. I have asked about that with all of those steps. It's better worded and a little bit easier to follow, but I like having you walk through the entire problem. So Amanda asks, why you calculated both of these? Yeah. So the question asks, how much carbon dioxide is produced. This first one only tells us how much oxygen gas will be consumed. So we need a way how to determine what the product is. You could have also started with the grams of methane and oxygen and converted to product and picked that way. But I choose a reactant to reactant in order to determine the limiting reactant. This equation calculates the limiting reactant, which we then used here to then determine how much CO2 would be created from the limiting reactant. Yes, I agree that more problems. The exam is a mix of can you do them quickly and efficiently, and do you know the material? My suggestion would be to study like it's a closed note exam, so that you want to work as many problems as possible. My guess is if you can work these confidently and get the correct answer, then you should be okay on the exam. If you can work them quickly, it will be better. But what day is the SI? Is there a practice exam for exam 1? Should be popped out. Any other questions? Because this is the end of today's material. I'm happy to stick around and answer questions. Otherwise, I will see you guys. I will be here on Monday for an exam review session. On Wednesday is our first exam. It'll be very similar to the mini exam. It will be there's a session tomorrow from 1 to 2 on limiting reactants. You guys should go. Limiting reactants is a top 5 difficult topic. Ooh, a study guide. Sweet. I will write that in my announcement. Excellent. It sounds like you guys are good. Mahi, I will send you an email so that I can get the right dates in my announcement this week. Y'all have a fantastic rest of the day. Anissa asks, how many questions is the exam? I haven't started writing it yet. Y'all have a great rest of the day. Feel free to hit up SI for more examples or send me an email. Bye, guys.